All right, Algebra 2. Welcome back, guys. We are in section 5 today. All right, talking about measures of central tendency and variation. All right, big old fancy words in here, but this is not a very tough section. And I also would definitely say that this video will not be as long as the last video. So we're going to get right into it. We start with things that you've already done. In fact, you've done this like a long time ago. We even did a little bit of it at the very beginning of the chapter in the intro to our chapter, mean, median, and mode. All right, what do they mean? The mean is the average, median is the middle, the mode is what occurs most often. You guys know how to do this. All right, there's going to be some problems where, yes, you have to do this. It's very easy, basic. We're not even going to go through that because that's how well I know you can do this. All right, but you have to understand mean, median, and mode to do some of the other styles of problems. What you are looking at right here, directly in the middle, this is called a box and whisker plot. All right, so given there's box, whisker. All right, so that's how they get the name box and whisker plot. And what this does is it gives you a visualization on a number line that uses all of the key components to a data set or to a list of numbers. All right, so you will have to figure out the median. You will have to figure out what's the smallest number, the biggest number, and then you're going to figure out the side averages, or they call them specifically the quartile averages. And that's this right here, the first quartile, the third quartile. So I'm going to walk you through a box and whisker plot. And then you also have this guy called the interquartile range, which that's the last piece of the box and whisker plot. And then once you have everything, the interquartile range, the IQR, that's really easy to get, just simple subtraction there. Okay, so I'll walk you through an example. And right here, though, this is an example that's already worked out for you. Okay, you need to read this. You need to take the time to read this. All right, I'm not going to read it to you. You guys can do this. Take the time to do this. This is one of those steps that's required to fully understand the stuff within this section, and of course, everything within this chapter. As I've said many times, the phrasing is important, all right? And up to this point, we've done a lot with phrasing and probability and all of the different things that can make one problem skewed because there's one word, like the word or, that can change everything, or at least that could change everything. But what you're looking at in this section is a little bit nicer, okay? Not so much in the term of word problems, because you could do a lot of just plug it in, get the answer, plug it in, get the answer. So that's going to be very helpful here. The next thing, again, I'm not going to read this to you because you guys can get it. Everything that's been highlighted there has to be read and copied. Again, read and copied. Ooh, all right, here we go. Last thing, gonna leave that up there. Gotta read it, gotta copy it. Gotta read it, gotta copy it. All right, good. Okay, let's get into some example problems. That way we can understand how to do it. You can see it. Okay, so this first one here, the probability distribution. So they've done a certain amount of events, and they're showing you all the different types of probability that go with this specific example. All right, so the number of accidents in a week at an intersection based on past data, it's given in this chart right here. All right, so we're going to be looking for this thing called the expected number. Really, the proper thing here is it's called the expected value. Okay, so again, expected value. And I'm giving you a little breakdown of this is what we're going to do to solve this. All right, to find the expected value, all you have to do is take the number of events. So if I scroll back here, this is the number of events. They're specifically saying number of accidents, but I make it a little more general when I say number of events. So here's the number of events, okay? And then you will be multiplying the number of events by the probability of that number of events. And that would be this part down here, the probability of those number of events occurring. So for 0 accidents to occur, there's a 75% chance. For 1 accident, 15%. For 2, there's 8%. For 3, there's 2%. So what we're going to be doing, I'm actually going to show you even how to plug this into your calculator. I'm going to write it out in exactly the way that you should plug this in. You multiply all the number of events by the probability of those numbers of events, and then add all your answers together. So here's how you should write this out in your calculator. All right. So we're going to go parentheses 0 times 0.75, which we know that's going to be 0. But I'm just showing you every single step here. 1 times 0.15 plus 2 times 0.08. Make sure those, you understand those are all decimals right there. Plus, and then the final one, 3 multiplied by a 0.02. Okay, this is all you have to do. All right, there's no looking around for phrasing here. They ask for it, and here's the simple way to calculate it. Plug that exactly like that into your calculator and hit enter, and you're going to get 0.37. Simple enough right there. Okay, and I want to make sure you guys are copying down full example problems. Let me say that, full example problems. If this is given to you, copy it down. Too many of us are taking a very, very short path into getting our answers, and we are just writing snippets of problems, which when you go back and look at that, it's not going to mean anything to you. So don't do that. Give me the entire example problem. All right. All right. So let's move into our second example problem. Now we will be making a box and whisker plot. Okay. So make a box and whisker plot with the data. Find the interquartile range. Simple enough. No special phrasing. Just do this. They're going to give you this entire data set right here. All right. It is not in any special order. You have to put it in order from least to greatest. That is step 1. You have to put a data set in order from least to greatest. Step 1. I have done this for you right here. All right. So you're going to be copying that down. Save time. It's already done. Now, step 1, real easy. What is the smallest number and what is the biggest number? Because that's going to make the far points of the whisker for the box and whisker plot. Okay? All right. So we're going to put a dot right here. We're going to put another dot over here. This one goes with 11, the smallest number. This one goes with 23. That would be our biggest number. Okay, after you have figured out the smallest number and the biggest number, now we need to figure out the middle number. All right, so the median. We need to figure out what is the median of this list of numbers that we have before us. Okay, so we're going to start by counting from one side into the middle, and then start on the other side and count into the middle. Where are we going to land? So we have 1, 2, 3, 4, 5, 6, 7, 8. That looks good. We're landing on 14. Let's do it from the other side. 1, 2, 3, 4, 5, 6, 7, 8. We're landing on 14 again. I know it's a different 14, but we're landing on 14 both times. So that does tell me that the median is 14. All right. And 14 is closer to 11. So we're going to put that right about here. There is 14. So now we have smallest, biggest right in the middle. Okay, now what we're looking for is we're going to be looking for what's called the lower quartile. The lower quartile is all of those numbers that are smaller than the median, and you don't include the smallest number though, okay? Because once this number's been used, we are pulling it out, meaning we're not counting it anymore. So just to make sure we understand that, we've already used 11 and we've already used 14. So all of these 14s are gone, and we've already used 23. So it is gone now too. Now what we're looking at is we have this group right here. That's going to give us our lower quartile. And then we have this group right here. That's going to give us our upper quartile. All right, so let's calculate lower quartile first. How do you do that? It's just what is now the median of only the lower quartile. Okay, so we have 1, 2, 3. 1, 2, 3. We are landing on 13 both times. So we're going to put a dot really close to 14. Let's get a red dot here. Really close to 14. That's going to be 13. Okay, now let's calculate the median of the upper quartile. That's going to give us our upper quartile. All right, so we have 1, 2, 3. 1, 2, 3. Both of these are landing on 18. Again, I understand it's not the same 18, but both land on 18. So we're going to plot this value right about here. This is giving us 18. All right, so now that we have all of our dots set up for the box and whisker plot, we need to make the box and the whisker. All right, so the whisker goes out to the biggest and it goes out to the smallest. And then we have the lower and upper quartile. Ultimately, that makes the box in the middle. And then you have to draw a line right there through the median. That is it. That is your box and whisker plot. All right. Now, the last piece that they ask for is the interquartile range, the IQR. So the interquartile range, you get this by taking the upper quartile, 18, and subtracting the lower quartile, 13, which means that our interquartile range is going to be 5. All right, you have to include all of that in your work and your solution. Okay, final example problem number 3 right here. We're going to use the calculator for this whole thing. All right, every step is written. We can zoom in just a little bit. Every step is written right there. Okay, zoom out just a teeny bit. Okay, so first thing, use the calculator, turn it on. You will be pushing the stat button. Push the stat button, and then the first category that is going to show up is edit, and number 1 is also edit. Hit enter, and make sure that your L1 and L2, for that matter, all of it is cleared out. There's nothing left in there from a prior old math problem. Clear it out. Now, in the L1 column, you will be putting the numbers that they give to you in the data set. Doesn't matter the order for this one. This is okay. Every number must be written in the L1 column. All right, so do that now. Plug in every number into the L1 column. All right, take the time to do that. Next, you will push stat again. Okay, push stat again. Then after you push stat, you're going to move to the right 1 time. and then take a look at number 1, and it should say var stats. Okay, so under number 1, it should say var stats. Hit enter, and most times you may have to hit enter again, all right, depending on if you have the TI-83 or 84 calculator. And then you're going to be given a list of all these calculations, different data, and there's going to be different math symbols next to them. I'm going to zoom in right here because these are the 2 symbols that you are focusing on. You're going to have an X with a line above it. That is the value for the mean. And then you're going to have, I believe we have a theta and an X right there. And that is going to be for standard deviation. So that way you do not have to do all the big calculations. The calculator is going to do it for us. All right. So when we do all of that, and they ask again for the mean and the standard deviation, and you plug those values into the calculator, go through all those steps, you will get a mean that is equal to 1.4, and then a standard deviation that is equal to about 1.6. All right, because those decimals keep going, especially for standard deviation. So there's your mean, there's your standard deviation. All right, guys, that is it. We're going to close it out. Okay, let's give you another random question here. Let's try to think of something. All right, if you could have any pet in the world, but this can't be one of your classic pets, can't be dog, can't be cat, can't be bird, can't be fish, what pet would it be and why? All right, we'll see you guys in the next video.